Okay, so today we are going to discuss about the Clarke and Park transformation. So we can say that in Clarke transformation, so here this both the transformations are part of reference frame transformation theory. So here we can say that the three-phase supply system supply source to it converts into a two-phase stationary system in Clarke transformation. Like if we can say that A, B, C are three phases in which are the cause of the rotating magnetic flux or rotating magnetic field, then in Clarke transformation we can convert the ABC into a two-phase stationary system which includes alpha and beta. And then this two-phase stationary system is further converts into a two-phase rotational system. Here alpha and beta convert into dq axis. Dq means in just like in DC motor, just like in DC motor, where d axis is the direct axis which is the cause of field flux, and to the perpendicular of this is the q axis or quadrature axis, which is the cause of torque in the DC motor, like DC motor. But it is this here we are converting the three-phase system just like to for our convenience, just like in a the DC motor. So we can say that the alpha beta frame is the just like this. In Clarke transformation, so this transformation is the Park transformation. Okay, so in lucid language we can say that in two convert the three-phase system into more conveniently understand the how the whole mathematical calculation done in the three-phase system. Where we can convert this the whole system into a two-phase just disk-like system, where we can have the two components of d axis, which is the cause of field current, field flux which is produced by that field current, and the 90-degree perpendicular to that is the quadrature axis, which is the which is here the cause of the armature flux, or here the cause of the torque, the current which produces the torque. And here on just like think of that three-phase system which is 120 degree apart from each another, and then we have to calculate that. So as an observer, while in the rotating magnetic field, we can say that as an we can say that we cannot implement those material we cannot understand how this this, or what I am trying to say, that in three-phase system, the supply current, which is the cause of producing magnetic flux, and the and the current, which is the responsible for the torque, is the same in the rotating magnetic field, which is provided by the three-phase supply. Okay, so we have to separate those current, which is the responsible for flux and the responsible for torque. So that's why we have to convert this three-phase system into a two-phase system, just like DC motors. So this is done by two parts, in three-phase system to two-phase stationary system, just like here, which is done by Clarke transformation. Okay, so here this is the mathematical part, is also large. We are going to cover later. So now the basic idea, what I am trying to say, that this is the two-phase stationary system, just like this. Okay, and then this alpha and beta, which are 90 degree apart from each other, and then this two-phase stationary system is converted into two-phase rotational system, just like in a DC motor, which is 90 degree, and then this whole part is uh, this whole part is actually rotates. Okay, actually rotates, and in an angle of theta we can calculate the actual rotation in a with respect to the stator flux. Okay, so this is the rotor flux, this is due to the rotor flux, and which is rotated with respect to the stator flux. So that's it, that's the main idea of Clarke and Park transformation.